Analog field device simulator. These are the assembly instructions. This is what we're going to put together. Now, this is one that was professionally assembled. We used to sell these fully assembled along with the digital field device simulator, also professionally assembled. The costs kept going up to get them assembled, and it really put them kind of out of reach. Rather than just drop the product, we decided to offer them as a kit. And we've offered the digital unit as a kit for quite some time. The analog kit's only been recent. Keep in mind, these were never designed to be kits. When you design something to be a kit, you plan it a little bit differently. These are still easy to assemble if you've got some good soldering experience and you can manage wires. Let's jump in here. And first of all, let's talk about what this analog field device simulator is. And there's two halves. The upper half is the outputs and the lower half is the inputs. Down on the bottom, we have 4 extendable inputs. What that means is that these 4 sets of binding posts are connected to 4 analog inputs on your PLC, on an analog module. Now, it could be an analog input module. It could be a combo analog input-output module. But we allow you to connect up 4 inputs. 2 of them, the 2 in the middle, they can be either 4 to 20 milliamp or 0 to 10 volts. The only source of an analog signal in this unit are the 2 potentiometers. The upper half, you have field extendable outputs. What that means is that the displays are going to be connected up to 2 analog outputs, and they will display 0 to 10 volts. They'll display voltage. Okay, if you can get more than 0 to 10, these particular displays will display like 0 to, 30 volts. These 2 displays are hooked up to your 2 analog outputs. In parallel with each display are these binding posts. That way, if you've got a 0 to 10 volt analog output, that voltage will appear on those binding posts, and you can extend those outputs to like a variable frequency device or some other device that you want to feed a 0 to 10 volt analog signal to. So the 2 in the middle of these inputs, they're external only. Right above them are 2 toggle switches. You just see gray circles. And you can switch between 0 to 20 milliamps or 0 to 10 volts. But only one of them can be connected electrically at a time. But you can run 2 wires from each of these channels, channel 1 and channel 2. You can run 2 wires back to your analog input module, one to the current terminal and one to the voltage terminal. And then this toggle switch selects whether you want what you have connected to these binding posts. We'll take input 1 there. If you've got a 4 to 20 source connected to those binding posts, then you want to flip the toggle switch down. It connects the wire from the binding post to the current input channel 1. If you flip the switch up, then it's going to connect these binding posts to the voltage terminal. A lot of analog inputs allow you to connect either voltage or current, but not both. Of these 4 sets of binding posts, the middle 2 do not supply anything to your analog inputs. All they do is switch the binding posts that you're looking at between either the voltage or the current terminal on the analog input module. It's up to you to connect your source or 0 to 10 or 0 to 20 on these binding posts. Whereas the outside set, those toggle switches switch between the potentiometer and the binding post. But the conductors that go back to the input modules can only be connected to voltage. Channel 0, channel 3 is voltage only. And you can pick between your voltage on the binding post or flip the switch up and pick the potentiometer. This is an internal 0 to 10 volt DC or external 10 volt DC. And the toggle switch picks whether you want to use the potentiometer or if you want to use the binding post. You could have something hooked up to the binding post and use the potentiometer, but you have to flip the switch to pick one or the other. You could actually have a 0 to 10 volt analog signal connected to the binding post there on channel 3, and you're using it in your program, and then you want to use the potentiometer value, and you flip the switch up, and now that's what your logic sees. You have two of these, channel 0, channel 3. These are the only sources built into this device, are 0 to 10 volts from those potentiometers. And these 4 toggle switches switch between the outside set, 0 and 3. They switch between using the potentiometer to control the voltage input, or to the flip it down, and it selects whatever voltage only that you've got hooked up to 0 and 3. Okay, this is a typical connection for an analog module. This is the 1769 IF4X OF2, very common, 4 in, 2 out. Now notice the wire colors. The wire colors are going to be the same ones that I'm going to use in the build of this kit. And usually the first thing that I connect up on the analog module, notice this is inputs and outputs, I connect up all the commons. I jumper all of the terminals on the analog input-output module. I jumper them all with black wires. And then when I bring a black wire in from the field device simulator, that will connect to any one of these terminals that are jumpered together. I've got it hooked to the top one. I tend to do everything to keep the wire as long as possible. And if something happens and it gets damaged, I can always use it in a shorter length. Not to worry. There's your wire colors, and you can see that these are the terminals that are all jumpered together that just went blue on your diagram there. Okay, if you wanted to hook up a differential voltage transmitter, it would be between, and now remember this is voltage, it would go to volts in channel 0 plus, and then the black would go to any of the black wires, any of the common, because they're common. And notice that this particular terminal is the blue wire. In our kit, when we build it, that will come from the potentiometer or from the binding post if you flip the switch down. Now, there's many things that you can hook up to here. Remember, you can do current or voltage. However, if you're going to do current or voltage, it's going to have to be to channels 1 and channels 2. 0 and 3 are already dedicated to voltage only in the way that we wired up our project. We would connect up the common from the power supply and the ground signal, and then we would hook up the voltage transmitter to volts in channel 0, and then the current transmitter would go to current in channel 1. It takes some getting used to looking at these terminals and how they're identified: VN 0 plus, VN 1 plus, and then V voltage or current in 0 minus. Now that's common for either voltage or current. If you look down through these terminals, you're going to see a V/I in for each of them. So if you look down the list there, you got VIN 0 minus, VIN 1 minus. Go down further, VIN 2 minus, and then down right below it, VIN 3 minus. I just connect all the commons together, whether I'm using the channels or not. Now notice that there are actually four screw terminals that are darker because I'm not connecting those at all. So remember, I told you channel 0 and channel 3 is voltage only. I don't have anything connected to current in 0 plus or current in 3 plus. And because I'm doing 0 to 10 volt output only, I'm not doing current out, then down at the bottom, you see I have nothing connected to current out 0 plus or current out 1 plus. Remember, there's only 2 channels for the outputs, and those are the 4 terminals down at the bottom of this. Current flow in this circuit would come from the minus side of the power supply, and then it would come out of the current in over to the current transmitter signal and then back to the power supply if you're trying to follow the circuit. This is for the output. So I have a voltage out connected. Now we're not going to do current, but if we were, that's what it would look like. You don't have any 4 to 20, 0 to 20. We don't have any current outputs connected on this digital field device simulator. What I'm trying to do is to show you both how we have it connected and how we're applying this analog field device simulator and what's left over on this analog module that we're not using. We're not using the current on 0 and 3, just voltage, and we're not using any current on the two outputs, just voltage. Okay, this is the kit. You got a power supply, power adapter, and then at the top you have two 0 to 10 volt DC displays. They can be 4-wire or 3-wire. The only difference is a 4-wire has two black wires, and then it's got a wire for the power for the display, and then another conductor for the signal coming in that is going to display. With a 3-wire, you just got one black wire, and it's common to both the power and to the display value. Actually, the 3-wire is nicer to use because you don't have so many wires to manage, which you will see here in a minute are quite a few. Right below it, you have 5 single pole double throw toggle switches maintained. And I will say this about these terminals, the lugs, the solder lugs, they will not accept more than one 22 gauge stranded twisted wire. You might squeeze 2 in, but it's going to be a real challenge. And these plastic housings are very heat sensitive. You apply too much heat to these toggle switches when you're soldering the lugs, it will soften the plastic housing, and then the spring tension that's on the toggle that makes it snap back and forth, it will expand and displace the mechanism, and you might as well at that point just pull it out and put in a new one. When you're soldering wires to the solder lugs on these toggle switches, make sure you use solder paste and make sure you're on and off. So you put the tip in there, I would apply it so you put more heat to the wire than the lug, and then start feeding the solder in. Let the solder melt on the tip. I know they tell you not to do that, but let the solder melt on the tip, flow onto the wire, and then push your solder tip over to the lug. And once you see the solder suck in, kind of, collapse into the crevices, then pull the solder tip off quick, and then tug on the wire after it cools to make sure you got a solid connection. Adjacent to the toggle switches, you've got 2 bulkhead connectors, and these bulkhead connectors have to match the plug on that power adapter that you see to the left. Matter of fact, you can see the tip of it sticking up. And I think these are 5.1 by, 2.2 millimeters, but you got to make sure they match. Now, in the case of the kit, they're going to match because that's all I buy. Right below there, you see 2 pieces of shrink tubing. You may or may not get those in the kit. That's not mandatory, but some people like to slide those on after you've done the center connection on the bulkhead connectors, just to make sure you can't accidentally squeeze them together and short them. Right below that is a 24 volt DC LED pilot light, and most of the time the terminals are marked plus and minus. However, you may have to hook it up to a power supply to see which one's actually plus and minus. The only thing that will matter is it's nice to put a red wire on the plus part and a black wire on the minus, just so when you're wiring it up, makes more sense. The 24 volt DC bore, or you want to call it a hole, over there on the cover, is between out 0 and out 1, says 24 volts DC. That hole is machined for the smallest LED indicator that we can find to add to the kit. That particular indicator you see over there underneath the pieces of red shrink tubing, that's slightly larger. I think it's 5/16. You're probably going to have to enlarge that hole, and using a unibit is the safest, easiest way. Otherwise, use your drill index and don't make that hole too big. That's bad news, because then you got to put a washer in of some sort, and then that covers up part of your 24 volt DC printing on the cover. Okay, below the LED indicator, you've got a little circuit board. That's a DC bucking circuit, and you're going to put 24 volts DC on that from this power adapter. You're going to adjust a little brass screw on that potentiometer to get 10.1 volts out of that, and that's what you're going to put across the potentiometers to give you your 0 to 10 volts. Right next to the circuit board is a little peel-off adhesive standoff, which you snap into one hole on that circuit board, and then you are going to press it into the bottom of this enclosure. That just keeps it from bouncing around. But I think you'll realize quickly when you assemble this, whether you do that or not, it's not going to bounce around in there because the box is full of wires. Because remember, you have to have enough length. You can split this back apart and connect everything and then put the lid back on it. When you do, the extra length of those wires is going to push that circuit board down right against the bottom of the enclosure. Right below there, you have two spring-loaded wire clamps that you can use as commons to slide in many conductors that need to all be joined together. Or you can twist the wires together, solder them, and throw a piece of shrink tube over them and shrink it down as a way to protect those ends from a short. Right below there, you have 12 to 14. There's always 12 in there. I usually try to make it 14 or 15 of these solder bushings, I guess you would call them. These get added to the 6 sets of dual binding posts you see right above. And most of them only get one of these. Some of them you might put in 2. And then a little bit further over, you see 2 potentiometers. Those are going to supply your variable DC voltage. Okay, first thing you're going to do to assemble this kit is disassemble all of your binding post sets. You got 6 sets. Take them apart, spread out the parts as you see here. In that upper left corner, I have one with the washers and the star washers. I have everything kind of laid out in sequence of how it's going to go back together, which will make sense in a minute. The first thing you want to do is prepare these to attach to the cover. Now, the easiest way to do this is to turn the cover upside down, slip one of these binding post sets in one of the elongated openings that are machined into it. And these openings are snug. What you can't see in the image is that both sides of these, if you want to call them the bases, you know, there's one half of the base goes on the face of the cover. The other half you see applied in the second picture. They actually have a ridge inside of them. So you go through this process and you start to tighten the nuts down. You're going to wiggle these around until they kind of slip right into these elongated openings. You put the other half of the base back on and then you drop in a washer. Next, you drop in star washers on both. Then you drop on the solder lug bushings or the solder lug tabs. Then you drop on another set of star washers. Then you drop on the other smooth washers. The reason I do it this way is I like when you tighten down the nuts, I don't want them biting into the star washer and then the other side of the star washer, it bites into something else and it wants to twist what's below it with what's above it. Try to keep the smooth surfaces on the nut and also on the base, and then that gives you a smooth rotation isolation between the star washers, the nut, and the base. Okay, another thing you're going to want to do before you tighten these down is loosen up the binding post nuts, of whatever you want to call them, on the outside until you at least can see the opening underneath of them. The reason you're doing this is because if you don't, typically they come screwed down tight. So when you try to tighten up the nuts on the back side, it's drawing these red and black nuts on the outside in really tight, and you won't get them loose with your fingers if you try to, loosen them up to slide a wire into one of those holes. Back those off before you do the next step. Now, I take the socket and use my fingers to snug down the nut on that stack of washers on the backside base of that dual binding post. And then I do that on both nuts and I kind of wiggle around the whole assembly until it looks nice and square and it feels like it's fitting down in that elongated slot. Once you've got them, you're comfortable with where they're at as far as aesthetics go. In other words, they look square and they look like they're where they're supposed to be. Then I tighten them down a little tighter, but there's no reason to go real tight because remember, you got lock washers and you've also got a lock nut. You can see in the first picture, tightening down a nut. In the second picture, you see that the locking nut is now spun on there. And then you can tighten those also with your socket wrench or whatever you're using for a wrench, but don't over tighten them. This stuff's not going to come loose. Now we go to the other 4 dual binding posts, and we go through the same sequence for each threaded piece, you know, smooth, star, solder lug, star, smooth, nut, and then tighten that down good, and then add the locking nuts. Now, I show some of these solder lugs sticking straight out and some bent. I would not bend them up like this unless you need to. In other words, once you start soldering, if you find that especially the ones over by the edge of the cover, if they're too close, they'll not touch. But when you're throwing your soldering tip down there and you don't want to hit the plastic and melt it, it won't hurt anything. It just looks ugly. Anyway, you repeat this, and now you got all 6 dual binding posts locked down with solder tabs. And you'll notice that I have 2 tabs on 2 of these binding posts, and you'll see why later. Here's what it looks like at this point. Okay, remember I told you you might have to open up the 24-volt DC pilot indicator, and this is a unibit. Unibits are really nice to have. If you're going to, work with making things, you got to buy one. Notice that when you do enlarge that hole, that pilot indicator should slip in there just perfectly. We're going to solder some wires to our bulkhead connectors. I use a clamp, and I also take the appropriate plug and plug it into the bulkhead connector to make sure that if I apply a little too much heat on that center connector that you see a red wire in, that it doesn't soften the insulation and then cause the center pin to move a little bit. I put that connector, and you can use the connector on your power supply. Just slide it in these bulkhead connectors when you're soldering them, and that way it will pull some of the heat out, act like a heat sink, but it will also keep that center pin located until the plastic cools. What I do is I take that red wire, strip one end of it, dip it in the solder paste, which makes it sticky. And then I drop it in that little reservoir there, and then I apply the solder tip to it and solder until it melts and flows in. Then I flip the clamp around that I have the bulkhead connector clamped into. I lay in the black wire. I just lay it in there, let gravity hold it in there, and then solder it up, and then trim it if there's too much hanging down. I do the same thing with the pilot light. And notice that the black wire goes to the minus. You can't see the plus on it, but coincidentally, you can see the minus with the black wire. Now, you can't depend on that. At this point, once you got the black and the red wire soldered on here, apply 24 volts plus to red, etc., to make sure that its polarity is correct. Now, if it's not, then you can just switch the wires around when you're assembling. So here's our 3 pre-wired, I guess you want to say, pre-soldered up objects that are going to go in our enclosure. Here is that bucking circuit. Notice you got plus, in, and plus. You got in plus and minus. Red goes to in plus and out plus. Black goes to in minus and out minus. 24 volts is going to go in, and what comes out depends on that brass screw on that little potentiometer. I would adjust this just as soon as you got it wired up. You got the wires on it, because it's easier to adjust it laying on the table than it is inside the enclosure. But you can still do it later. Okay, solder up red and black wires to it and make them plenty long enough to reach anywhere in your workspace. When I say workspace, I'm thinking if you take the 2 halves of the enclosure, you take the top off and then lay it right next to it, that's your workspace. Any wires that have to go between the upper half and the lower half should go to connect on both ends. It should be long enough to reach anywhere. Okay, now let's start wiring up the common, which is the black wire that goes throughout the whole system. So I'm down in the lower left-hand corner looking at the back, and I take a long black wire that's going to extend up to the upper half. So it's probably 7-8 inches long. I lay it in the solder lug opening, and then I take a shorter piece, stripped on both ends, and then I slide it in both solder lugs. The spring tension holds that wire in there. Now, you don't have to do this. You could just lay one end down and then solder the first one, and then put the other end of the short wire into the next one, and then bring the next black wire in and just lay it in there, solder it up, and then follow suit all the way across the bottom of the inside of this cover. And notice the last black terminal. Now, if you flip this over, you'll see that these are the black binding posts, not the red ones. But you see a black wire going off. Make that at least 7-8 inches long, because that has to reach somewhere into the workspace to bring the negative side of the bulkhead connectors into the upper half of the enclosure. Okay, this is the continuation of the common in the upper half of the cover. You see that black wire here? You see it over to the left. It goes up. It goes on up, and it goes to the black binding post that has 2 solder lugs on it. You notice that in those 2 lugs, one of them is the common coming up from the bottom, and the other goes over to the next black binding post. And then the other solder lug, it goes to the potentiometer, and it also goes to the 2 black wires on one of those displays. Remember, all the black wires get soldered into the same circuit. It all is connected together. Now, notice that with the potentiometers, it looks like you've got a black wire going into the top of one and the bottom of the other. But if you think about it, if you were to rotate either one of these potentiometers around so it's facing the same way, you would see this is the same end. And you got to be really careful what you're doing here, because you want your knobs, when you're using it, when you rotate it clockwise, you want the voltage to go up on both of these knobs on these potentiometers. Just make sure you connect these up right. Okay, now we've got our common bus completely connected for the upper half on the cover, and I've taken all the red wires and I've kind of clumped them together just to get them out of my hair. Now, you've got 5 red wires there, and when you look at those displays, and remember these are 4-wire displays. If you had 3-wire displays, they would be simple. The blacks all go together, but the bottom red, that is 24 volts DC to power the display. The upper red wire is going to come from your analog output to display the value of your analog output. I pull them all up out of the way for now. Next thing I do is I take your bucking circuit and I take that standoff and I snap it into one end of it, and then I peel off the back and then I push it down against the bottom of the enclosure. Now remember, that's just to hold it in place, because once you have this all wired up, and if you wired it up with this circuit card basically laying there, not connected, in other words, not attached to anything, it's not going to go anywhere, and it's not going to short to anything, guarantee you. But I put in this little standoff, and you only need one for peace of mind that this thing can't move around. Okay, now we're looking at our whole workspace, okay? And we've done a lot of work over here on the left, all of our negative or 0 volts DC. And we've got our bucking circuit peeled off and stuck to the bottom of the bottom half of the enclosure. We've also installed our 2 bulkhead connectors and tightened those nuts down. Now you're going to have to get clever to tighten those nuts down with a couple pair of needle nose pliers, but don't get frustrated. Just take your time and you can get them snugged down. Next thing we did is we started connecting up our toggle switches. Now what I'm showing you here is one toggle switch. It doesn't matter which one it is. It just happens to be the one that's over on the left when you have the cover in front of you with the top of it away from you. What I wanted to show you was that typically when I solder these wires, I just lay it in the opening and then carefully bring in the tip and the solder and solder it up. The old days where they wanted you to make a mechanical connection, in other words, put the wire in and then bend it over. It can't come off when you're soldering it. You can do that if you want, but you're going to get frustrated. I just lay it in there and I apply the solder tip mostly to the wire, and then I slide it over against the lug, and I feed the solder in and let it melt and transfer the heat. And as soon as I see the solder kind of fall into the crevices, that means it's fully wetted. Pull the tip off quick. If you see the solder joint right below it, that purple wire and the solder lug going to a binding post, discoloration, by the way, that's the resin that's inside the resin-filled solder. But you see that there's no clump, that the solder has flowed between the solder lug and the wire. Then the wire that you see connected into the bottom lug on that switch on your left, the one that's laid in there, that gets soldered. Then it gets bent around and stuck in the center lug on the potentiometer right above it. Now notice that it's just sitting in the hole, and it's the, you want to call it the spring tension or the hysteresis in the wire that's holding that conductor, the bare end of it, up against the top of that eyelet on that pot. Apply solder, and these lugs can handle a lot of heat. If you put too much heat here, it'll just melt the end of the plastic insulation like you see right above it on the black wire. And so this is one potentiometer toggle switch binding post circuit. So you see the top lug on the switch goes down to the solder lug, the red binding post right below it. And then the bottom lug on the switch goes up to the center lug on the potentiometer. Now, you can trim off excess wire from any of these solder lugs. The potentiometers, you can see I don't bother. You can see a little piece sticking out there from the purple wire, but down on the switch, you see it sticking out a little bit. Now, most likely, I'm going to take my little skinny needle nose, or my little skinny cutoffs that I use for cutting tie wraps, and slip it in there and nip that off. That's just a habit. But if they're not touching other wires, don't worry about it. Okay, now we did the same thing with the other sides. The purple is channel 3 and the blue is channel 1. Now remember, we're looking at this, we flipped it over. So flip this cover over right in front of you, that would move the purple over to the right and the blue over to the left. And it really doesn't matter what channels they are, but you see that the circuits are identical. We have black going to the same end of the potentiometer, and then we're going from a binding post to the top solder lug on the switch, and from the bottom solder lug on the switch up to the center of the potentiometer. These are the two potentiometer circuits. Now we're going to do the binding posts for the two middle channels, channel 1 and channel 2. In this case, they go to the center lug. Now I know the orange wire, it's kind of hard to see, but it is soldered to the center lug on that switch. Typically, I will solder the wire to the center lug on the toggle switch, then cut it and strip it, and then solder it to the solder lug on the binding post. And you want to make them long enough so they're easy to handle. And as you can see, if you got a little excess length in order to allow you to handle it better with your fingers in a tight space, you just push it down flat against the inside of the enclosure there. Now, this is the first step where we connect the two halves of our enclosure. Remember, we applied this bucking circuit to the bottom of the enclosure with that peel off standoff. And now we're going to take the out plus over to the top lug on that potentiometer, and then over to the bottom lug on the other potentiometer. That completes the circuit for 10 volts out. Remember, you got to adjust the potentiometer there on the bucking voltage board, little brass screw. You've got 10.1, 10.2. You just want to make sure you have a full 0 to 10 volts DC on that potentiometer for your analog input. Now, this is where it gets ugly. I have two of those spring-loaded wire clamps there. These are nice because you can always flip the little orange levers back up and pull the wires back out if you don't like it. But the upper one, the one closest to the top of the image, that's going to connect everything that needs 24 volts DC into one connection. Notice the bottom red wires from the displays go over there. The top red wire from the power on-off switch, which is the center lug, goes over there. And then you've also got something that's going to go down to the bucking voltage, the plus N. So you've got a number of things. There's really only four things that need power, 24 volts DC. The pilot light, you see it goes over there. The two displays need power. And then the bucking circuit, which you can't see, it's just right below the edge there on the bottom half of the enclosure. All that gets connected to that one. The other spring-loaded clamp comes from the two bulkhead connectors where you plug in the wall adapter, and then it goes to the power on and off toggle switch. That's the power, and the other one is the switched power. And you notice I got a third one. In my case, I got a third one for the black wires. If you don't get a third one, you just twist all the black wires together, solder it, and then take shrink tubing and slide over that bare conductor, all soldered together, and shrink it down tight. Another view of the same thing. In this case, you can see that the plus N for our circuit card there, the bucking circuit, is going up. It goes behind that one spring, that clamp connector, but it goes over to the other one to get its 24 volts DC. Just another view of the same thing. Now, I hope you're watching this whole thing before you start connecting yours, before you build it. Another thing I do at this point is I take my 9 conductors, all color-coded. You see them coming in through that hole there, the other unused hole on the enclosure. You see brown, white, purple, orange, blue, green, white, gray, whatever. And I feed that through the hole, but what I did was I put a little light knot on the other end just to kind of hold them together and make them more manageable. Now I start soldering them up. Okay, this is important. This is one of your displays, and if you're looking at the back of the cover, this would be the one in the upper left. Notice that I bring the red wire from the upper white connector on the display down to this terminal, and then I brought in a green wire, that great big long bunch of wires that comes in through that hole in the bottom half of the enclosure. Those two go in there. Now, if you're looking, that's not a bad solder joint. You see the black ones looks perfect. It's just smooth and there's no lumps anywhere. The red and green one, the solder joint is good, but when I was pulling off the solder tip, I hesitated and the solder started to harden. And you see those little sharp things sticking out. Don't worry about that. I wouldn't even go back and trim them off. Just make sure that the solder joint is good. There is your connection between 3 things. The upper red wire, which is the voltage in for the display itself, the value, analog value. The green wire that goes to your analog output on your module. And then the solder lug that goes to the black binding post, the red binding post on the front of this thing. And then if you look to the other picture, you're doing the exact same thing, but with a gray wire. And it's the other display. Okay, this is looking at your purple circuit again. It's one of the either potentiometer or binding post circuits. What I'm showing you here is that you need to make sure you have no conductor or anything conducting between these 3 terminals. Now, it's not real clear, but I can see clearly that there is no metal between one solder lug and another. They're all clear of each other. These aren't going to get bent together. You can always reach your side cutters down in there and snip off any excess. Be careful not to break anything that you need there. And this is the blue one. Now, in the case of this one, if you look at the center lug, and I know the solder joint looks clumpy, that's because I pulse the heat. I make sure that it makes a good solder joint, and then I go back in and maybe add a little bit more, and it tends to end up looking like that. It's a good solder joint, but you see the strands sticking out the bottom of it towards the space between the center lug and the bottom lug. Don't worry, I wouldn't bother trimming that off. Remember, this is 24 volts DC at best, and you don't have to have much of an airspace to prevent arcing. Believe me, trust me. A piece of paper, thickness of airspace would be enough. Okay, now we go to the 2 middle toggle switches, and between these 2 pictures, you can see what's going on. So the red binding post of channels 1 and 2 go to the top lug on the switch. Go to the center lug on the switch. It's really hard looking at these pictures. You can see with the orange a little bit better than with the yellow. When you look at the yellow, goes from the binding post, it actually goes up to the center lug, and then the other two lugs are yellow and brown. Then if you look at the one right below it, the orange goes from the binding post to the center solder lug. Then you got orange and white connected to those. Now, if you're going to use the same color code that I use, you need to do them exactly like this. Purple goes to that top center toggle switch lug, and then the next one, yellow goes to the middle, and yellow wire going out to your analog input is that yellow goes to the bottom, and then brown also going out to a terminal on your module is brown. You see that toggle switch switches the yellow that goes from that binding post to the yellow that goes to the center. The center goes from the binding post. If you flip the switch down, then it goes to the brown. If you put the switch up, it goes to the yellow. Basically, using that toggle switch to pick what terminal on your module that this binding post terminal goes to. Same thing with the orange and orange-white. I know that sounds a little bit confusing. This is a better picture. And at this point, I've taken the wires that go to the toggle switches and to the binding post up there for the outputs, and I've kind of swept them together a little bit more neatly and put a loose tie wrap on them just to keep them out of my hair. So if you look closely now, this is your best picture of those toggle switches. The binding post, purple, goes up to the top of the toggle switch, and then the potentiometer goes down to the bottom lug on the switch. And then the center solder lug on the switch goes out with all the other wires to your input module. The blue and the purple are the same. And then the yellow and the orange, the binding post comes up to the center lug on both the orange and the yellow. And then on the yellow, that toggle switch is going to switch either the brown or the yellow from the binding post going out to your module. Same I did with the orange and the orange-white. Notice that I also have all of the blacks all connected into that other spring clamp switch or spring clamp connector there. You don't have to use one of those. They can just be soldered together and put some shrink tubing over the exposed conductor, because once you get this far and everything is functioning correctly, you'll probably never take this lid off again. Extremely unlikely. As long as you've done a good job electrically, good solder joints and nothing shorting, you'll be good for as long as you use this thing. Now, this is something that takes a little bit more finesse. What I've done is I slid on a piece of shrink tubing, which I may or may not put in the kit, because remember, I'm not supplying you any wires, okay, or solder. You need to get a piece of shrink tubing. Well, you don't have to. You could actually use black electrical tape, but either way, I have a piece of shrink tubing slid on all the conductors that go through this hole, and I have it laying right here, right where I want it to be when I put the lid on, okay? Now what I'm going to do is I'm going to leave it right in that position on those wires. I'm going to pull it back to the right until it's fully exposed, and I'm going to use my heat gun to shrink that shrink tubing down on that bundle of wires. Then I'm going to pull it all the way out the other way, and I'm going to take my strain relief, which I always try to include one of these in the kits, even though, I always try to include one because the strain relief has to match up with the hole that you're going to push it into and what you're going to put through the middle of it. The one reason I use the shrink tubing is to take up a little of the space. When you snap it into the hole on the enclosure, it fits nice and snug. It's always a balancing act between the size of the hole, the size of the strain relief. You could put one more piece of shrink tubing over that spot and then slip the split bushing strain relief over it. Snaps in more difficult, so it pulls out more difficult. However, this is what I did. Just push it in there, and then the last step is I put a tie wrap as close as possible to after I've snapped that strain relief in, That way, if the bundle gets pulled outwards, it can't go past that tie wrap, okay? You don't even need any of this. Those wires could go right out that bare hole. The edge of that plastic hole is not going to damage the insulation on those wires, believe me. But just in order to make it look neat and tidy, this is what we did. Okay, and Bob's your uncle. There you got it. You put the lid on, and these screws that hold the lid down, they actually thread through the upper half, then into the lower half, which means that when you're putting in these screws, you'll be threading them in, and then all of a sudden it'll slip downward, and that allows you to remove this cover and not have them fall out of the hole. It retains them. It's a nice design. This company makes really nice enclosures. Now, when you tighten down these screws, I don't put them real tight, and I do one corner, then the opposite corner snug, and then I do the other two corners snug, and then I tighten them down a little bit more, and then that's it. So you plug in your 24 volts DC, flip on your on and off toggle switch, and it should light up. Now, you're probably thinking, what's that 3/10,000ths of a volt? Well, it's irrelevant, whatever it is. Now, you don't need this many decimal places. This could be really should only be a 3-digit display, 0.00. You don't need those other because it's irrelevant. However, these displays are getting really difficult to get that fit in this exact square opening. And if I can no longer find them, then that means I have to retool the machining of these covers for a different size display. And it can't be any bigger. It would have to be the smaller ones. I'm hoping it doesn't go that way. Okay, I hope you watched this whole thing before you started soldering yours up. Thank you.